Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper trending on X, published on July 2nd, 2025, just 2 days ago. It introduces a new reverse reward method that pushes a model's performance on the GSM 8K math benchmark to an impressive 96.1%. The paper is titled LEDOM, an Open and Fundamental Reverse Language Model, 2507.01335 versus 1. And it explores the fascinating idea of training language models to think backwards. This paper introduces LEDOM, the first purely reverse language model, and shows it has unique reasoning abilities. Alright, so the first figure really visualizes this core idea perfectly. We see a sentence fragment, sat on the mat, being fed into what the authors call a reverse language model, or RLM. Now, unlike a normal forward language model, or FLM, which predicts the next word, this reverse language model is trained to predict the previous word. So given on the mat, it predicts sat, and given sat on the mat, it works backward to predict cat. This approach is a fundamental flip of how we usually think about language generation. This table then lays out the architectural details for the models they built. We can see two sizes, a 2B and a 7B parameter version. The key takeaway here is that the authors used an identical structure, a standard transformer decoder, for both their new reverse language models and the forward language models they compare against. This includes things like the number of layers, which are like processing steps, and attention heads, which let the model focus on different parts of text. This identical setup is crucial because it isolates the training direction as the only difference. Moving on to the results, this table compares the performance of the reverse and forward language models across a set of benchmarks, which are basically standardized tests for AI. The results are really fascinating. On tasks that are naturally forward-looking, like generating code in the human eval test, the forward language model does much better, as you might expect. But on some general reasoning tests, like Boole Q, the reverse language model is surprisingly competitive. This shows that training a model backwards doesn't just make it worse, it gives it a fundamentally different kind of reasoning ability. Okay, and this next table gives us some really concrete examples of what that different reasoning ability looks like. It shows various task categories, with the reverse language model generating a logical beginning from a given ending. For instance, in abductive reasoning, which is like finding the best explanation for an observation, it creates a backstory from a single concluding sentence. It can also generate a question from an answer. Crucially, this table also highlights a potential safety risk, showing how the model can bypass normal safeguards, which is a really important finding. So, given these unique abilities, how can we actually use a reverse language model to improve results? This diagram illustrates the core idea, which the authors call reverse reward. It's a clever way to combine both models. First, a normal forward language model generates several possible reasoning steps. Then, the reverse language model, LEDOM, scores each one by calculating the probability of the original question given that step. The darker blocks show the paths that get the highest reverse reward, essentially guiding the reasoning process toward the most logical conclusion. And this table really puts that reverse reward concept to the test on some tough mathematical reasoning problems. We see several powerful math models, like DeepSeek Math and Quinn Math, tested on benchmarks like Math 500 and GSM 8K. For each one, the results compare a few strategies. There's greedy decoding, which is just the model's standard single best guess. Then, there's the best of n strategy, where the model generates multiple answers. The key comparison is when those answers are selected using the reverse reward. And as you can see, using reverse reward consistently produces the highest scores. So what we see here is that using this reverse reward strategy, where the reverse language model scores the outputs of a normal model, leads to some really impressive gains in mathematical reasoning. In conclusion, this work introduces LEDOM, the first purely reverse language model, trained autoregressively, which means it predicts the past based on the future, one word at a time. This challenges the long-held assumption that forward prediction is the only way to build powerful models. The key takeaway is that this reverse training gives the model a unique, complementary reasoning ability. and when used as a reverse reward system, it can significantly boost the performance of standard models on complex tasks. That's all the time we have for today's AI Research Roundup. Thanks for listening, and I'll see you next time.